Today I'm going to talk about an approach to adding notifications features to custom analytical applications. So a little bit about me. I work at a company called Intermix. We do performance monitoring for data platforms. And prior to that, I was working at a company called Criticism and Intelligent, which was performance monitoring for mobile applications. And then earlier in my career, I co-founded one of the first cloud computing companies and hold a bunch of patents in that area. So this is really geared towards individuals who might be involved in projects where you're building like a custom advanced analytics application for your company to deliver to partners or customers or to make the product better or for internal use. So think D3 charts or other sort of charting applications that you build yourself. And so at some point, what will happen is that your customers will love it and they'll want the ability to send emails or SMS to themselves when certain charts behave in certain ways. And so this happened to us. We had built our product as a monitoring tool, so we've got pretty charts and things like this that we show our users. And you know, this is like a bird's eye view of your cluster, and then it shows you throughput information about stuff happening in your environment. And they love it so much that, but they don't really want to be logging in every single day and looking at your data. They just really want to be able to get, salient information quickly. This is good news. It means that the data that you're providing to them is useful. And so when these requests to add notifications come in, you have two options. You can build a notification system yourself. And this is an ability to set thresholds for certain metrics and rules in a rules-based way, and then point and then send emails and notifications to various channels, which turns out is very, very hard to do. Or because most of your users are already using a tool like CloudWatch or Datadog, just push your metrics into those tools instead. Turns out is the approach that we decided to take. And so a few considerations when thinking about how to do this that our team sort of considered were, on the end side, you need to deal with all the abilities, right? You need to think through what additional complexity am I adding to my application, to my infrastructure to do this? How easy is it to manage this? How will it scale? And then how durable is it? Fault tolerance is obviously very important when you're talking about analytics. When thinking through what to build from the product perspective, what kind of tools will you want to support in the future? I mean, if most of your users use CloudWatch, some use Datadog, others use Wavefront, you will get requests to push stuff into those tools as well. So you should think through in advance how you would do that. What metrics will you send, and then how will these things change over time? From a cost perspective, you really want to focus on a solution that does not require you to make a big capital upfront expense. What you really want is to be able to only pay a variable cost as new users sign up or as you add additional metrics to the tool. So what we ended up doing is setting up an approach where the metric data that's built on our platform, is that better? Where we went an entirely serverless approach. So our platform stores data in Elasticsearch and Redshift. In this diagram, Clio represents the Docker farm that runs a lot of our ETL. And so what we decided to do is add a queue and then add a worker that will pop messages off of that queue and push it into the notification system of choice. And we decided to use Kinesis and Lambda. And so the way that the system works is we have workers that will generate metrics. They will push them onto a Kinesis stream. And then we have two Lambda functions. One is the async. It is an async Lambda function that will pop messages off of the Kinesis queue. And then it'll trigger another Lambda function that will actually push the messages into CloudWatch in this case. And so I'll talk a little bit about like how how this approach works and what were some of the trade-offs that we made. So this is a great this approach that we evaluated some of the other options that I'll share later. Really gives you an ability to not have to worry about scalability because Amazon deals with that. it's a low latency solution. The nice thing is that it's very durable. There's a dead letter queue in Lambda, so any message that fails to be delivered, either because the CloudWatch API is down or the API of the notification system is down, the message with the body is stored in a queue for reprocessing. Perhaps the best feature of this architecture for us was that we could multiplex this data and support multiple notification services without having to make big changes to the architecture. So if we wanted to support a system in addition to CloudWatch, like Datadog, all we would have to do is either extend the Lambda function to push the message body into both services at the same time, or just build another Lambda function that would be tailor-made for that one service's API. And so we wouldn't have to change how the producers created the metrics and pushed them onto the queue. The cons is that it was for us, we were not using Lambda or Kinesis at the time, and so it's a wholly separate sort of kind of infrastructure that we had to figure out how to monitor. Our setup, I'm not going to bore you with the configuration on the left, but essentially the thing is Lambda functions can only run for 5 minutes at a time. You can get around that by fanning Lambda out, but anything that you do, you need to make sure that the operation will take less than 5 minutes in general. Some of the cost metrics were interesting. It's not free, but it is pay-as-you-go. So the metrics that we were pushing were on a 1 minute granularity, which turns out, when you look at the message body for us and the amount of memory being used by the Lambda server, turned out to be about 0.73 or 73 cents per month, which doesn't sound like a lot, but it does add up, sort of add up. If you think about all the metrics that you might push across all the combinations of how those metrics might be aggregated, this number could get into the hundreds of dollars per month. So it's something to manage. But at least when you start, you're starting at 0. One of the things that was interesting is that Lambda has at least one semantics. We assumed that it was exactly one semantics, which we learned the hard way after debugging for a few hours. Apparently, the Google service, Google Functions, has exactly one semantic. So if this is important for your application, you can sort of play around with that other service. What this means is that the same message can be delivered more than once with the same body. So you just have to have your application deal with that. For us, it didn't matter for this application because it would just end up being 2 sample counts within CloudWatch for the same data point, which did not change the aggregation of the metrics. With CloudWatch, you cannot delete data. There's no API to delete metrics, and so if you want to get rid of a custom metric, just stop pushing to it, and then it'll be automatically pruned and go away after 2 weeks. One of the other nice things is that Amazon deals with aggregation for you. So you don't have to really worry about aggregating data as it gets older. The final one was, for our product, in order to connect to our customer's CloudWatch environment, we had to set up a registration flow whereby they would authorize one of their roles, a trust relationship with our certain Amazon account. And it turns out that with CloudWatch, you cannot get very granular with what kind of permissions you can assign. You cannot say, for example, I only want to read metrics from this service. You have to, it's required that you do star, that you get kind of all access or nothing. That was a problem for us because we really wanted to be able to read back the data that we pushed to do data validation, but we weren't able to do that. And so we don't do data validation at all. No, so we had to find a different way to do that, but that's something that was surprising to us. It's not very easy to get granular. It's impossible to do that with Amazon. We had evaluated a few other approaches. I'll share a little bit of those here. We had, on the left-hand side, we did a queue plus a worker. We sort of looked at using our own queue instead of using Kinesis. The pros of that would have been that it would have been sort of simpler to code because we already had our Docker farm that we could have leveraged for this. But then we have to manage a queue, one more queue, and deal with the scalability of that. We had also evaluated not using a queue at all, but that was something that was clearly not a good idea because of the fact that we would be very, very dependent on the performance of the notification system, and we'd have no way of recovering from failures, which was not acceptable. So in practice, the way that this looks is in our application we have these charts, and we have a function where, in this example, it's kind of hard to see, but when you click on the chart, you can now send any of the analytics for this chart into CloudWatch. In this case, we're streaming row count information, size, information for tables, aggregated by schema into CloudWatch. And then that sort of shows up as a custom namespace in CloudWatch, which is kind of nice. So you can have as many of these as you want. And they sort of, in the message body, whatever you put in the message body as the name of the custom namespace, it just sort of shows up in Amazon CloudWatch. It's impossible to change, so if you mess up the name and want to change it, you have to add a new one and then wait 2 weeks for the old one to go away. But this is like what it looks like, and then you can easily set up alarms. This is an example of a time series of number of rows in a particular database table over time. So that's it. Thank you very much. Any questions?
Do you consider SQS views?
We had not considered SQS views, and there was a specific reason, and I forget why. Sorry.
Oh, that's fine.
Yeah.
Could you, to be clear, so when you were saying that Lambda had at least one semantics, that means that the actual requests would get actually run more than once sometimes?
Yeah.
Okay.
Yeah.
That was not part of my mental model, so I was kind of shocked by that. I can't imagine.
Yeah, it wasn't mine either.
Okay.
Yeah.
Yeah. Oh, yeah. For the.
So I did notice that in your configuration you have the kinesis batch set to 1. Can you sort of elaborate on that decision? And I wouldn't be shocked if that's related to exactly one semantic.
For us it was because when we were starting to roll out this, like we're a small company, and so we didn't really need that much scale to start with. So we started with 1 because we didn't really need more than that. Yeah.
Okay. The reason I'm asking that question is I'm also a practitioner on the same stack, and that is related to invocation because your Lambda is charged by invocation.
Right.
So if you process one request at a time, potentially you will increase your invocation count. But obviously I don't know the context of the problem you're dealing with.
Yeah, we have 2 Lambda functions. One will pop the message, so we will serialize the metrics before they go into kinesis. And so each of the message bodies is just one data point.
Did you consider using Apache Kafka instead of Kinesis?
So we did not, because that was just way overkill. There's no, for us, we're kind of a small team, and so there's no service whereby we could launch Kafka very easily.